Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Last month, a SaaS company got their AWS bill. Single region, $3,848 per month. Their new multi-region setup, $28,858. That's not a typo. That's 7.5 times more expensive. Not the 2x that AWS sales promised. Not the marginal increase their consultant suggested. 7.5 times. And that's before we talk about the 1,000 engineering hours it took to implement. Today, I'm going to show you exactly why multi-region really costs this much, when it's worth it, and most importantly, when it's not. This is episode 1 of Multi-Region Platform Engineering, AWS, Kubernetes, and Aurora at Scale. If you're a senior engineer or architect thinking about multi-region, this lesson might save your company hundreds of thousands of dollars. Or it might give you the ammunition you need to justify the investment. By the end of this lesson, you'll be able to explain the fundamental trade-offs between cost, complexity, and capability in multi-region architectures. You'll calculate the true cost multiplier, not the marketing numbers. You'll determine when single region is actually the better choice. And you'll have a decision framework to assess if your organization really needs multi-region. We're going to cover 3 main areas. First, I'll introduce you to the cost, complexity, capability triangle, the mental model that governs every multi-region decision. Then we'll expose the hidden single points of failure that exist even in supposedly multi-region architectures. And finally, we'll break down the real costs with actual numbers from production deployments. Before we dive in, make sure you're comfortable with basic AWS services like EC2, RDS, and S3. You should know what an availability zone is. And you should have at least heard the terms RPO and RTO. We'll define them properly. But this course assumes senior engineering experience. If any of those are unfamiliar, pause and do a quick review. We're going to move fast. Let's start with the mental model that changes everything. Think about multi-region architecture, like the classic project management triangle. You know the one: fast, cheap, good, pick 2. Except here it's cost, complexity, and capability. You want all 3? Physics and economics say no. Picture a triangle in your mind. At the top vertex, you've got capability. That's your 99.99% uptime, your global low latency, your disaster recovery, the ability to survive an entire AWS region going down. At the bottom left vertex, you've got low W cost, minimal infrastructure spend, minimal data transfer charges, minimal engineering time. And at the bottom right vertex, you've got low complexity, simple operations, fewer moving parts, less expertise required. Your on-call engineers can actually sleep. Your single region setup? It sits comfortably along that bottom edge. Low cost, low complexity, but limited capability. Want to move toward that top vertex? Want that capability? You're going to drag cost and complexity with you. There's no escaping it. Here's what nobody tells you about the real numbers. Infrastructure duplication gives you a 2x baseline. 2 regions equals 2 sets of everything. That's the easy math. But then data transfer kicks in. $0.02 per gigabyte between regions. Doesn't sound like much? 100 terabytes per month, which is nothing for a decent-sized app. That's $2,000 extra per month. And it gets worse. Every microservice interaction now potentially crosses regions. That API call that was free when it stayed in US East 1. Now it costs money. Every single call. Want centralized observability? Great idea. Except now you're shipping logs cross-region. Your Datadog bill just doubled. Your CloudWatch cost tripled. That's another $2,000 per month you didn't budget for. And we haven't even talked about engineering time, 500 to 1,000 hours for implementation. That's conservative. I've seen teams spend 6 months getting multi-region working. 6 months of your best engineers not building features. Total it up? 2.5 times cost for a simple setup. 7.5 times for anything complex. And complex sneaks up on you. You start simple, then you need a service mesh for cross-region communication. Then you need specialized networking. Then you get the idea. But here's the thing that really frustrates me. AWS tells you it's just running in another region. Like, it's that simple? Deploy your CloudFormation template in US-West 2, and boom, you're multi-region. No, you're running everything twice, syncing constantly, and your team now has to handle distributed systems complexity that makes single region look like a walk in the park. I know, this sounds pessimistic, but I've watched too many teams blow their budgets because they believed the marketing. Now let me blow your mind with something else. You've deployed to US East 1 and US West 2. Congratulations, you're multi-region. Except you're not. Several critical AWS services share control planes across regions. Services you depend on. Services you can't work around. Route 53? That's a global service with its control plane primarily in US East 1. When you update a DNS record, where do you think that change originates? IAM? Changes propagate from US East 1 globally. Your perfectly distributed multi-region setup depends on one region's control plane. ACM certificate manager issues certificates from specific regions. Your HTTPS traffic depends on regional certificate infrastructure. CloudFront? Control plane in US East 1. Here's the kicker. 35 to 40% of AWS global traffic routes through or depends on US East 1 in some way. December 7th, 2021, US East 1 went down, not just a little hiccup, a major outage. You know what else went down? Parts of US West 2, parts of EU West 1. Services that should have been isolated weren't. Because of these shared dependencies nobody talks about. Here's how I audit for real multi-region capability, and this is something you should do before spending $1 on multi-region. First, I list every AWS service we use. Every single one. Then, I check which ones have truly regional control planes. Not regional endpoints. Regional control planes. There's a difference. Finally, I identify the shared dependencies. The hidden coupling. Usually, I find 3 to 5 services that completely break the multi-region promise. Services you can't avoid. Services that are core to your architecture. That multi-region setup you're planning, it might not be as resilient as you think. Let me show you the real numbers, not the hand-wavy estimates, the actual bills. Our SaaS company started with this monthly breakdown in a single region, EC2 and EKS. $1,200. Pretty standard for a mid-sized application. RDS Aurora, $800. Single writer, couple of read replicas. Internal data transfer, $200. Moving data between services, availability zones, load balancers, $300. Application load balancer, network load balancer, storage, S3, EBS, $500. Other services, $848. Lambda, SQS, SNS, the usual suspects. Total, $3,848 per month. Reasonable, manageable, predictable. Then they went multi-region. EC2 and EKS in 2 regions, $2,400. Okay, that's the expected doubling. Aurora Global Database, $2,400. Wait, what? That's not double. That's triple. Because Global Database isn't just Aurora in 2 places. It's Aurora with special replication, special endpoints, special pricing, data transfer, and here's where it gets painful. $8,000. $8,000. That $200 of internal transfer became $8,000 of cross-region transfer. A 40 times increase. This is what kills budgets. Load balancers plus global accelerator, $900. You need the global accelerator for routing. That's extra. Storage doubled plus replication costs, $1,200. Observability? This is new, $2,000. Why? Because you need centralized logging, centralized metrics, centralized tracing. All that data flows between regions. All of it costs money. Service mesh, Istio in this case, $500. Extra infrastructure for cross-region communication. NAT gateways in multiple regions, $400. Forgot about those, didn't you? Engineering contractor to help with setup, $10,000. One-time cost, but amortize it over a year. That's $833 per month. Other services doubled, $1,058. Total, $28,858 per month. Look at what exploded. Data transfer went from 200 to 8,000. The database went from 800 to 2,400. Observability appeared from nowhere at 2,000. And that engineering contractor, that's just the external help. Not counting your internal team's time. This is reality. This is what multi-region actually costs. Now you might be thinking, okay, it's expensive, but we need the resilience. Do you though? Let's talk about when single region actually wins. Because for most companies, it does. If your revenue is under 10 million per year, stop right here. You don't need multi-region, period. Do the math with me. 10 million in revenue divided by 8,760 hours in a year. That's about $1,140 per hour of downtime. Your multi-region premium? $25,000 per month. To break even, you'd need 22 hours of downtime per year. Know how much downtime a well-architected single-region setup has? 2 to 4 hours. Per year, you're spending $300,000 a year to prevent downtime that costs you maybe $4,000. That's not insurance. That's lighting money on fire. Can you tolerate 1 to 4 hours of downtime annually? For most businesses, the answer is yes. Your customers might grumble. They won't leave. Not for a few hours once or twice a year. Are your users geographically concentrated? 80% in North America? You don't need multi-region for latency. CDN handles static content. Your dynamic content is fast enough from one region. Do you have regulatory requirements for geographic redundancy? No? Then you don't need multi-region for compliance. Here's the big one. Do you have a dedicated platform team? Engineers who live and breathe distributed systems? Who can handle split-brain scenarios at 3 a.m.? If not, multi-region will cause more outages than it prevents. I guarantee it. You'll have data consistency bugs, replication lag issues, failover procedures that nobody really understands. That multi-region setup designed to prevent outages, it becomes the cause of outages. I've seen it happen multiple times. A company builds for problems they don't have. What if an entire AWS region fails? It happens once every 2 to 3 years for 2 to 6 hours. Is preventing that worth $300,000 per year? Plus the engineering complexity? Plus the operational overhead? For a $10 million company, that's 3% of revenue. For resilience, you'll use once every 3 years. Single region with good practices beats poorly implemented multi-region every time. Before we continue, pause and think about this. What's your current monthly AWS bill? Write it down. Multiply it by 7.5. That's your realistic multi-region cost. Can your business afford that? More importantly, can your business justify that? If your company has 5 million in revenue, should you go multi-region? The answer is no. At 5 million revenue, downtime costs about $570 per hour. Your multi-region premium of $25,000 per month requires 44 hours of downtime per year to break even. Single region with proper availability zones gives you 2 to 4 hours of downtime per year. You're 40 hours short of break even. Now let's also address those hidden costs nobody mentions. Route 53 health checks? Those cost extra when checking multiple regions. IAM cross-region role assumptions? They have API rate limits that you'll hit during failover. ACM certificates? You need them in every region, and they all need to be maintained. That US East 1 dependency I mentioned? When it fails, your careful multi-region architecture might not save you. You've paid for resilience you don't actually have. Let me be clear about something. Multi-region can be the right choice. If you're Netflix serving video globally with revenue that makes downtime cost millions per hour, absolutely go multi-region. If you're a financial services company with regulatory requirements for geographic redundancy, you don't have a choice. If you're running a global e-commerce platform where every minute of downtime during Black Friday costs hundreds of thousands, the math works. But for most companies, most SaaS applications, most startups, single region is the right choice. Optimize that single region. Use multiple availability zones. Have good backups. Practice recovery procedures. Monitor everything. That will serve you better than a complex multi-region setup you don't understand and can't operate properly. Let's recap what we've covered. First, multi-region costs 2.5 to 7.5 times more than single region. Not the 2x vendors claim. Data transfer is the silent killer, often costing more than the infrastructure itself. Second, the cost complexity capability triangle governs everything. You can optimize for 2 vertices, never all 3. Choose wisely. Third, hidden single points of failure exist even in multi-region setups. Route 53, IAM, ACM, they all have shared control planes, often in US East 1. Fourth, 80% of companies don't need multi-region. Do the math. Calculate your actual downtime cost. Compare it to the multi-region premium. The numbers rarely work. Fifth, engineering time is often your largest hidden cost. 500 to 1,000 hours of implementation, plus ongoing operational complexity. This triangle framework, cost, complexity, capability, will guide every architectural decision throughout this course. Every building block we examine, every pattern we discuss, fits somewhere in this triangle. Master this mental model, and you'll make better decisions than engineers who just follow best practices blindly. Before we dive into the technical building blocks in upcoming episodes, you needed this reality check. Multi-region isn't primarily a technical challenge. It's an economic and organizational one. Solve the economics first. Make sure the math works. Make sure your organization can handle the complexity. Then, and only then, tackle the technical architecture. Next time, we're exploring production patterns in the wild. What companies actually build versus what they claim to build. You'll discover why 62% of enterprises choose hot-warm, not hot-hot. We'll look at the real RTO and RPO of each pattern, not the marketing numbers, the actual measured times from production failures. And I'll show you why Netflix's architecture wouldn't work for your company, and what would. We'll see how different companies position themselves on our cost complexity capability triangle. More importantly, you'll learn to recognize which pattern fits your actual needs, not your aspirational ones. The pattern you choose determines everything else. Get it wrong, and no amount of engineering excellence will save you. See you in the next lesson.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.